Hi, welcome to a product tutorial by Robojax. This is SunFounder's PiCar-X Raspberry Pi self-driving robot car kit.
Hello friend, how are you? Turn left here. Count down to 3 seconds. 3, 2, 1. Rock. I lost.
I'm at the SunFounder's documentation page. Here on the left side it says play with Python, and then click on calibrating PiCar-X. First let's ping to see our robot is connected. I'm pinging with IP version 4 so you can see the IP as well, and this is the hostname .local. So we got connected. Now let's use SSH pi add hostname, this hostname .local, and it asks for the password, and I got connected. Let's run this portion of the command cd. I'm already there. PiCar. I pressed the tab key to complete it. Example and calibration, and enter. So I'm in this directory now. Now let's run this portion. Sudo python 3 cal, and I pressed tab. So we got this screen, and from here we can do the calibration. The instruction is all on the screen here. Now we will be using W and D for increasing the servo angle, S and A for decreasing. So these are the default one. R for servo test, and then Q for change motor direction, and E for motor run and stop. So these will work continuously, and here it will show us what we do. Right now it says direction servo, so it means option 1 is by default selected, and if the motor is selected or not, we will see it in here using these options. So the values are here, and then for the offset that we are doing, for each value for the servo we are entering the value. These are for motor, these 3 values are for the servo. Let's test the motor. So I'm pressing E on the keyboard, and E again will stop it. Press Q to change the direction. I'm pressing now Q. You see, Q. So this was E and Q for the motor direction, so we can check it to see if it's running. So the motors are running perfectly. Now we can do for Now we can do for a servo test R. So this is the steering and all of the servos. So 1 R is for all of them. I'm repeating it. So they're working. We can do the direction servo. This is our steering servo. If when you stop it, if it's not straight, you can calibrate it in here. I'm pressing now 1. Already 1 was selected. To change the value, we can do W and S. I'm pressing W. Now pay attention. I don't know if you can see it. I'm pressing E, and slowly this is rotating. I'm pressing W, and this is now going to the right. Now it has turned to the right. Now to go back, I'm pressing S or A. I'm pressing A now. Multiple times. So this way we can do it, and you can see the value has changed here. If you are happy with the value, this is for the steering. We just press space to confirm. I'm pressing space and it says yes. I'm pressing Y. So calibration for this has been saved. Now let's go for the camera pan and tilt. If the camera is, for example, right now it's looking too high. If you want to put the default to be a little lower, so that's called the tilt. I'm pressing 3 for the tilt. Now the tilt servo is here. Now the same way we can use W and S to move it. Pay attention here. I'm going down now. You see now it's too low. Now I'm pressing A to bring it a little up. So if you are happy with this, now this is the value. We can press space and yes. We could do it for all because the value will be saved once, but I just did it. Now for the pan as well, if you see now, right now it's a little to the left. Let's do the pan 2. Now it shows pan, and the same way you can press W is taking it to the left, so I'm pressing A, and the value is changing here as well. So if this is straight enough and you are happy with this, and then let's press now space to confirm and yes. So the calibration have been saved. To exit from this screen, press Ctrl and C. So I pressed it twice, so the first one exited. Now let's see how we can add scheduler or run our script. Now let's see how we can run a program or a script when the robot turns on. So first let me show you the location of the file that we want to do. Let's type cd PiCar example, then run the move.py. Let me run it again. So I'm pressing up arrow key, so it moves, and then it's steering, and then the servos. So it moves in a line. If I do the ls or dir, so we can do dir home PiCar-X example. We have all these files. I'm going to create another script with different name, so I'm not going to touch this. First I'm going to copy it to a folder. Let's create a folder. To know current working directory, print working directory pwd. It will tell you the location. So this tilde is an alias for this. Now I'm going to create a directory called Robojax, mkdir Robojax. Now if I do dir, it will show the PiCar-X and Robojax. Now we want to copy the move inside this folder. So cp copy home PiCar-X example, and then move, and then that this is the source. We need one space and then destination. Home Robojax, and then the name of the file, Robojax. I want to name it Robojax move, so I know it's my custom file. Enter, and it has been copied. Now if I do ls Robojax, you will see that we have this file located. This portion is done. Clear. Now let's go to the scheduler or cron tab. We type sudo cron tab -e. This is the scheduler and the cursor is in here. I'm using arrow to come down. At the bottom we just type at reboot, so when it's rebooted we will run a Python 3 program or script which is located at this path, full path, home pi robojax underscore move .py. Once you wrote it, then we can write it out using Control O or Command O and enter. Then we have to exit using Control X and then exit. Now it's done. Let's reboot our robot. I'm gonna type sudo reboot now, and as soon as I press enter, let's wait for this to reboot. You see the light is still on and now it's blinking, which means it's rebooting. Still blinking. So it worked, and the servo and everything. So the move script will run this way. Every program that you write and you want to run it, put it in the cron job. If you want to have multiple script run, so you can put next line and next line, but the problem is that if this program takes time, the next program will not run until this is finished. So you have to manage that yourself. So this is robot hat, which is like a hat on top of Raspberry Pi. Once you connect it, all the GPIO opens will be connected in here and they will be available. The rest we can use them as usual from these connections or from these connectors. The GPIO pins are combined here with some extra chips here. We have separate microcontroller. These are two motor drivers. We have digital to analog converter, DAC, and we have pulse width modulation pins, and here these are also digital output pins. We have built-in charge controller. Once you connect it via USB, it will charge your battery, and we have a voltage regulator here which regulates it for the purpose of 3.3 volts and 5 volt supply. And we have when you connect the battery, there are switches that will turn on and off the charge and protect your battery. So it has battery protection and charge, everything connected in here. And then we have a quick connector here for I2C, and we have I2C communication pins in here. SPI pins are available in here. If you want to use UART or USB, these are the pins that you can connect it. The main on off, we have user switch and we have reset switch in here. The speaker is at the bottom of this robot hat module. pulse width modulation control very easy, because once you send the signal comes here, and this microcontroller will take care of the signal that you send. This has very extensive documentation, and here is the documentation page for the robot hat. This is the page, and as you can see, shutdown current is less than half a milliampere, and USB-C input is 5 volts 2 ampere. It says charging power 10 watt or 2 ampere, output power 5 volts 3 ampere, because this will supply it from the battery. The battery that is included is a 2-cell battery of 3.7 volts lithium 18650, and the connector is XH2. This is 2mm 3-pin, and it has reverse polarity protection, and the charging, under voltage protection, and input voltage protection, charge balancing, and overheat. So it has all the protection that is needed for the battery. On board we have the charge light indicator, we have the power indicator, and then 2 battery level indicators. On board USB LED and 2 tactile switches. It has 5 volts 1.8 ampere, 2 motor driver, 4 channel 12 bits analog to digital converter, and 12 channel pulse width modulation, 4 channel digital signal, SPI, UART, I2C, and 8 ohm 1 watt speaker. Here are the other detailed information for the charging exact voltage if you need it. 4 sets of 3 pins. So you see here 1, 2, 3, 4 sets. There are 3 pins, and these are the robot hat D0, D1, D2, D3, and each is numbered. 0 is, for example, GPIO 17 if you want to use it in programming, and the same way for 1 is GPIO 4. All the pins are mentioned here. So these are Raspberry Pi, Raspberry Pi 4, and the different versions of Raspberry Pis. And if the button says reset, it is connected to GPIO, for example, 19. User button is MISO pin. Analog to digital converter, ADC here. They have built in this type of 1% voltage divider, and here it says how to get certain voltage or output. And for pulse width modulation here, these are the pins that are available. I2C pins are in here, as I mentioned, and these are SPI pins. And the pins, for example, busy clock channel select or clock M out, these are the Raspberry Pi pins corresponding to these on robot hat. LED and buttons, for example, LED is connected on GPIO 26, user pin is connected to GPIO 25, reset is connected to 16, and the rest of the pins, as you can see, the motor direction 1, power direction 2 for motor 2. So this is motor 1 direction, and motor 1 power, motor 2 direction power. So the power is about the speed, this is about the direction. So these are the GPIO pins. Battery level indicator for charge balancing. If 2 LED is on, the voltage is greater than 7.6. If 1 LED is on, 7.15. The voltage is greater than 7.15. If both LEDs are off, then it's less than 7.15 volts. The battery is 2000 milliampere hour, 90 grams. It's lithium ion, 2-cell, and over discharge protection. This is incorrect. Over discharge protection. Over discharge should be around 4 volts, or I don't know, something less than the nominal voltage. And microcontroller that is on the robot hat is this microcontroller. You can view the documentation online, and all the other information are available here. Here are the API reference for robot hat. Once you import robot hat as a code, these are from the class. We can call the pen, DAC, pulse width modulation, and if you are using external module, the class already has code for these modules. For example, ultrasonic, which you are using for sound. We are not using any of the other one, but these are all available. For example, for motor control, if I click here, it shows the documentation. So you can, in your code, you can say from robot hat import motor, and the motor, you will create your own object and then select motor wheel with the speed. So with this speed, 100%. So the documentation is very well prepared and ready for you. Thank you for watching. I will see you in the next lesson.